The next topic of engineering mechanics is system of forces. Okay, so definition of system of force and classification of system of forces. Okay, and definition of the all types of system of forces. Okay, see here, system of forces. Then what is the meaning of system of forces? Okay, see here, so consider one body. Okay, so now I am taking forces F1 and F2 and F3 and F4, okay, F5 and F6. Okay, so the several forces acting simultaneously on a body is called system of forces. Okay, so what is the definition of system of forces? Okay, several forces. See here, F1, F2, F3 and F4 up to etc. Okay, the several forces acting simultaneously on a body is called system of forces. Okay, clear? The system of forces are classified into two types. First one is the coplanar. Okay, so the next one is the non-coplanar. See here, so coplanar and non-coplanar. Then what is the meaning of coplanar? So what is the meaning of non-coplanar? Okay, see here, the coplanar means the line of action of all the forces acting in a single plane. Okay, see here, now I am taking one plane. Okay, so the forces, see here, the forces acting on single plane. Okay, so that is known as coplanar forces. That means the line of action of all the forces lie in the same plane. That is known as coplanar forces. The next one is the non-coplanar forces. Means the line of action of all the forces acting in different planes. So that is the known as non-coplanar forces. Okay, so coplanar means the line of action of all the forces acting in a single plane, and so in this case all the forces acting in different planes. Okay, see here, so in coplanar forces, so divided into four types. See here, collinear, concurrent, parallel, non-concurrent, non-parallel. Okay, so in non-coplanar also divided into four types: collinear, concurrent, parallel, non-concurrent, non-parallel. Okay, then what is the meaning of collinear forces? Collinear coplanar forces. See here, this one is the coplanar. Okay, so this one is the non-coplanar. So this one is the collinear coplanar force. See here, so coplanar means all the forces acting on a single plane or lie in the same plane. Okay, see here, in collinear means the line of action of all the forces acting in a straight line, so lie in the same plane. All the forces lie in the same plane. Okay, that means, see here, now I am taking one plane. This is the planes, one plane. So F1 and F2 and F3. So these forces acting in a straight line. Okay, so within the plane. That means all the forces acting in a single plane. Okay, so that is known as collinear coplanar forces. The next one is the concurrent forces. See here, so concurrent coplanar. So this is the plane, so single plane. Okay, see here, now I am taking different forces and F1, F2 and F3, F4 or F5, okay, or F6, so whatever may be. So okay, so all the forces, okay, so meet at one point. Okay, so that forces is known as concurrent forces. Clear? Okay, So that means F1, F2, F3, F4, F5. So all the forces are intersect at a point. Okay, so that is known as concurrent forces. The line of action of all the forces intersect at a point lie in the same plane. That is known as concurrent coplanar forces. Next, parallel. Okay, see here, parallel coplanar forces. So now I am taking one plane. This is the plane. So this one is the F1 and F2 and F3. Okay, so all the forces are parallel to each other. See here. So F1 and F2, so both are parallel to each other, and F1, F3, so both are parallel to each other. F3 and F2, so both are parallel to each other. Okay, the line of action of all the forces parallel to each other, so within the same plane or lie in the same plane. So that is known as parallel coplanar forces. Okay, see here, the last one is non-concurrent, non-parallel. Okay, so non-concurrent, non-parallel. So what is the definition of non-concurrent and non-parallel? See here, so F1, now I am taking one plane, single plane. Okay, so F1 and F2 and F3. Okay, so concurrent means, so all the forces meet at one point. Okay, so parallel means all the forces are parallel to each other. See here, now I am taking F1 and F2 and F3. So these are so all the forces are not parallel to each other. And see here, so this one is intersect at this point, this one is intersect at this point. But how to define non-concurrent, non-parallel forces? Okay, see here, the line of action of forces are neither parallel, so nor meet at a single point. Neither parallel nor meet at a single point. So that is known as non-concurrent, non-parallel forces. But all the forces are lie in the same plane. That means within the same plane. All the forces acting within the same plane in coplanar forces. Clear? Okay. So collinear means all the forces acting in a straight line. So within the same plane or lie in the same plane. Okay. Concurrent means all the forces are intersect a single point. Okay, so within the same plane or lie in the same plane. So in parallel, so parallel to each other. All the forces are parallel to each other, so lie in the same plane or within the same plane. So non-concurrent, non-parallel means neither parallel, so nor meet at a single point. That is known as non-concurrent, non-parallel forces. Okay, so this one is the coplanar force. Next, now I am going to explain the non-coplanar forces. See here. So in this case also divided into four types. First one is a collinear. So already you know the collinear forces. This one is a collinear coplanar. This one is the collinear non-coplanar. Means, see here, collinear means all the forces acting in a straight line. In a straight line, it may be horizontal or vertical. See here. Okay. So in collinear non-coplanar forces, all the forces. See here. So this is the diagram of collinear. So F1 and F2. No, so please consider F1 and F2, and see here X and Y and Z. So I am taking different planes. Now I am taking different planes. Okay. See here. So F1 acting here and F2 acting here. Okay. So these two forces acting so in different planes. Okay. But how to define collinear non-coplanar forces? Okay. See, all the forces, that means the line of action of all the forces acting in a acting in a straight line, but in different planes. All the forces acting in different planes. Okay. So this is known as collinear forces. The next one is a concurrent non-coplanar forces. In concurrent, so all the forces are intersect at a point, that is known as concurrent. Okay. So in this case, say here F1 and F2 and F3. Now I am taking so different forces. Okay. So X and Y and Z. So these three are different axes. Okay. Next, see here, all the forces are meet at a single point, but so these forces acting in different planes. See here. So F1 force acting between X and Y, So F2 force acting between Y and Z, F3 acting between Z and X. Okay, so that is the main difference. Next, parallel. So parallel non-coplanar forces. See here, now I am taking X, Y, Z. So F1 force acting between X, Y. Okay, next now I am taking this one is the force. Okay, so this force F2 acting between X and Z. Okay, see here, the line of action of all the forces parallel to each other but acting in different planes. Okay, so that is known as parallel non-coplanar forces. Okay, so finally non-concurrent, non-parallel. So what is the definition of non-concurrent, non-parallel? See here. Okay, so the line of action of okay of the forces are neither parallel and nor meet a common point, okay, a common point in different planes, so that is known as non-concurrent, non-parallel forces. Okay, so this is the system of forces. Okay, so if you have any doubts, so please ask me. Clear? Next one is equilibrium and equilibriant definitions. These two definitions also very important in engineering mechanics. See here. So what is the definition of equilibrium? Okay, see. So when a rigid body is at rest under the influence of external force, okay, so that is known as, or that body is known as equilibrium. Okay, so before a discussion of the equilibrium, so already you know that rigid body. So rigid body means they do not change the shape and size of the body, so by applying the external force. Okay, that is known as a rigid body. See here. So now I am taking, so this is a pen. Okay, so force is external force acting on your body, but there is no change shape and size of the body, so that is known as a rigid body. Okay, see here, when a rigid body is rest under the influence of external force. Okay, so now I am taking board, so this is a rigid body. Okay, so see here, when a rigid body is rest under the influence of external force. See here, so now I am applying forces on rigid body, but there is no change. That means constant. See here, there is no movement is there. Okay, so that is known as equilibrium. Okay, next one is equilibriant. So if a body is brought into equilibrium, okay, so see here, by applying a single force. Now see here, now I am taking, okay, so one body. Okay, see here, so how to brought into equilibrium position? By applying a single force. See here, so now I am taking, this is a body. Okay, so this one is the force. Okay, just I am applying the force, single force on a body. Okay, so then it will automatically change into equilibrium position. See here, equilibrium position. Okay, so that means if a body is brought into equilibrium by applying a single force, that force is known as equilibriant. Okay, so that is known as equilibriant. So these two definitions are very important. Okay, one is next topic is constraint, action and reaction. Okay, so what is the meaning of constraint? Then what is the meaning of action and reaction? See here, the definition of constraints, action and reaction. So now consider one ball. Okay, so this ball is resting on frictionless horizontal surface. See here, so C is the center point of the ball. Okay, so W is the weight of the ball. Okay, so this one is the horizontal, frictionless horizontal surface. Okay, so what is the definition of constraint? So please listen carefully. A ball resting on, see here, a ball resting on frictionless horizontal surface cannot move vertically downward, cannot move vertically downward. Okay, the horizontal surface, this horizontal surface restrict the motion of the ball in downwards. That is known as constraint. Clear? Okay, so what is the definition of constraint? A ball resting on frictionless horizontal surface, okay, so cannot move cannot move vertically downwards. The horizontal surface restrict the motion of the ball in downward direction. That is known as constraint. Next one is action. Okay, so what is the meaning of action? Definition. See here, the ball, see, now I am taking this ball, the ball press surface with a force equal to weight. Okay, so what is the definition of action? A ball press, see here, a ball press surface with a force equal to weight. So that is known as action. Okay, that means the weight of the ball, okay, so acting on this surface, so that is known as, so the weight of the ball acting on the surface. Okay, how much force? W force. Okay, the W force acting on that surface, that is known as action. Okay, so what is the meaning of reaction? So according to Newton's law, so every action equal to, there is opposite reaction. According to Newton's third law, so every action, okay, so equal to, so opposite reaction. See here, the ball weight, that means the ball weight, okay, so weight of the force acting on surface. See here, so according to Newton's third law, so every action, okay, so equal to, there is opposite reaction. Okay, so according to Newton's law, then force acting on surface, okay, so there is opposite forces also acting on that surfaces. Okay, how much? Then W equal to RA. So this RA is known as a reaction. Okay, so these three definitions also very important.